We are going to go through the different states of matter and particularly the water cycle. So now the three states of matter, water exists in three states: the solid, liquid, and gas. So examples of water in the solid state would be, of course, ice and snow. Like a beaker of ice, or if you take a look at a close-up of a snowflake, you will see that it's actually a solid. So examples of water in the liquid states would be rainwater, river water, well water, so on and so forth. So in the gaseous state would be, of course, steam and water vapor. What is temperature? So temperature, when we're talking about how hot or cold water is, we're referring to its temperature. There was a particular question that asked, what's the difference between heat and temperature? So the difference between heat and temperature is that heat is the energy and temperature is just the measure. Yeah, so we use degrees and Celsius to measure, and of course we use the thermometer to measure. So now let's go to the more important things right now. Yeah, first one is freezing. Okay, what is freezing? So when water loses heat, its temperature falls. Water placed in the freezers loses heat until the point where it falls to 0 degrees Celsius and it changes to ice. We say that water changes from the liquid to the solid state. So this process by which water changes to ice is called freezing, and the freezing point of water is, of course, 0 degrees Celsius. Next, we talk about melting. So ice taken out of a freezer gains heat and its temperature rises. When the temperature of ice falls to 0 degrees Celsius, it changes to water. So when ice changes to water, we say that ice changes from the solid state to the liquid state. Ice made from water containing impurities will freeze at temperatures below 0 degrees Celsius. For example, if you have salt water, you try to freeze salt water, it's not going to freeze at 0 degrees Celsius. Instead, it will freeze when its temperatures falls below 0 degrees Celsius. Next, we talk about boiling. So when water is heated, it gains heat and its temperature will rise. When the temperature rises to 100 degrees Celsius, it boils and changes to steam. We say that the water has changed from the liquid state to the gaseous state. The boiling point of water is 100 degrees Celsius, and the boiling point of water is also known as the steam point. Now, what if it contains some impurities? Right? Water with impurities will boil at temperatures above 100 degrees Celsius. Okay, example, salt water will not boil at 100 degrees Celsius. Instead, it will boil when its temperature rises above 100 degrees Celsius. When some sugar or some sand is in the water will either stop boiling or boil less vigorously. This is because pure water boils at 100. When you add sugar, the boiling point of the syrup is raised above 100 degrees Celsius. Next, we talk about evaporation. So what is evaporation? When a container of water gains heat, the surface water changes into a gas known as water vapor. We say that the water changes from the liquid state to the gaseous state. The process by which water changes to water vapor is called evaporation, and it takes place all the time at any temperature. So the rate of evaporation refers to how fast water changes to water vapor. The following factors affect the rate of evaporation. Number 1, temperature, presence of wind, and the exposed surface area and humidity. Let's talk about temperature. So the higher the temperature, the faster the rate of evaporation. On the other hand, the rate of evaporation is slower when the temperature is low. For example, when you have a wet clothing, it dries faster on a hot and sunny day than on a cool and cloudy day. So next factor will be the presence of wind. So the stronger the wind, the faster the rate of evaporation. On the other hand, right, the rate of evaporation is slower when there is no wind. So for example, if you just came out from your showers, you have wet hair, it will dry faster when it's blown by a fan than when left to dry on its own. Next factor is the exposed surface area. So the bigger the exposed surface area, the faster is the rate of evaporation. On the other hand, the rate of evaporation is slower when the exposed surface area is small. For example, if you have a wet towel that's spread out, it dries faster than when it is folded. Lastly is humidity. So the humidity refers to the amount of water vapor in the air So the higher the humidity of the air, the slower is the rate of evaporation. Next, we talk about condensation. Now, condensation is a topic that is always being tested in PSLE, so we're going to take some time to go through this. So what is condensation? So when water vapor or steam loses heat, it changes from the gaseous state to the liquid state. The change of state from gas to liquid is known as condensation. For example, if you have water vapor in the air, it will condense into water droplets on the surface of a cold glass. Right. Steam from the kettle will lose heat to the cooler surface of a glass sheet and condense into tiny water droplets. So those are examples of condensation. Okay. So let me explain what's going on here. Okay, for this question, because the sand is wet, right? We start with the wet sand. So the beginning is about the sand, which is wet. It evaporated to form water vapor. So the water here evaporated from water vapor, lost heat, condensed onto the cooler inner surface of the cloth. So when you touch this, it became water droplet. Since cloth is made of so you can just say that therefore it absorbed the water and the cloth became wet. Okay? That's all here. Okay, how about B? Explain why the temperature of air in setup Y decrease over time. Why the temperature of air in setup Y decrease over time? How come here the temperature, there's a thermometer here, right? So the temperature decreased. So it's another explain why question. Okay, so this is for part A. Okay, I'm gonna go through. Right, let's go through this. Now you've done this a zillion times, yeah? So actually the answer is here. Okay, why the hot buns became wet? Now when they're hot, there's like warm water vapor inside, right? So warm water vapor come into contact with the cooler inner surface. Okay, where's the cooler inner surface? It's right here. The cooler inner surface, warm water vapor touch that, lose heat. So that's what we're looking for. Okay, lose heat, yeah? So lose heat, condense, see keyword, condense to become water droplet, drippets down, drip down.
This will be dripped.
And made the hot buns wet. Okay? See? Very standard stuff. Okay? And of course, the next mandatory question is the holy question. Right? If one you poke some holes, one you poke many holes, why is it that the one with when you open the buns in the box A were wetter than B? Okay, so I'm not going to go through it. Yeah. All right. Basically here, the one in box B, what happened? Yeah, tell me what happened. Water vapor can escape, right? So here water vapor escape. Here less water vapor escape, so more of them condensed. Okay. Here more water vapor, here less water vapor escape, right? So let's see how many types of variations of holes are there. You see, here's another one. It's the same stuff, right? I'm not going to go through this. So here is another variation. No, they didn't ask you about it being wet. They say, how come the rice in container G became cooler than the one in F? Sorry, this should be F. That's F, huh? So how come the one in G became cooler? So here is cooler, whereas this one was not so cool. The rice not so cool. Same reasoning, yeah? So there are holes. What happened? Water vapor can escape, right? So because water vapor can escape from here, it does okay. Which one will lose heat faster? Container G lose heat because the question is about cooler, so you got a reference to heat loss. So this one lose heat faster. Why did it lose it faster? Because there are more holes. Okay, more holes, water vapor escape, lose it faster, and therefore it became cooler. Alright? So then they go back to water droplets again. So in container F, this one, after some time, water droplets will form. Why? Same stuff, yeah? Warm water vapor come into contact with the cooler surface here, lose heat, condense. Okay, is it okay? Okay, so the plastic sheet is a poor conductor of heat, therefore heat there's less heat. There is less heat loss in the tunnel. Hence, okay, so warmth is needed. Now the second reason is about water vapor. Water, yeah. So okay, so will help. Basically, I want to end with they all will help the seeds germinate faster. Right? Having the plastic sheet, I will always end with hence this will help it to germinate faster. So water vapor condense to form water droplets. They'll drop back, yeah. Next one. Okay, so which one will dry faster? So we know it's B, right? Okay, why? So I'm gonna type this out. It has exposed. It has a bigger exposed ratio. So should be has a bigger exposed surface area. Okay, hence it dries faster. So you gotta mention that water evaporates at a faster rate due to bigger exposure ratio. Most students might just stop here. They will stop here. Oh, bigger exposure ratio. But you haven't explained why. So what? If you have a bigger exposure ratio, the water can evaporate at a faster rate.
Faster rate.
Yeah, hence it dry faster. So how hanging the sheets at the same location make this a fair test? So the wind, the wind and the amount of sunlight, the temperature is the same, right? You gotta talk about wind, the amount. Okay. Okay, so the answer is dish X is cooler. Stop it here. Right, so it's dish X. It's cooler than surrounding room temperature of 30 degrees, hence water vapor from the surrounding, which is 30 degrees, lose heat when it comes to the contact with the dish X. Condense to form water droplet. Okay, Sam, do you understand this, Sam? Sam. Can? No, can? Okay. Move on. Oh, that's it. This is cooler than so warm water vapor. Yeah, alright. So good. Next one. Now windscreen problem. So temperature inside or outside. Now you see the mist form on the inside. So what's the difference in the temperature between inside and outside? Which one colder? Is it the inside or the outside? Huh? Outside, inside. Wait, mist is inside. That means water droplet is inside, correct? That means condensation took place inside. That means warm water vapor touch the cooler surface. That means outside is cooler than
the inside.
Hey, you nearly say warm. Outside cooler than inside. No. You know what's the problem? Most Singaporeans, I mean, because we travel in vehicles, usually inside is cooler than outside, right?
Yeah.
But then in other countries, winter, cold countries, right? This thing can happen. The outside is cooler than the
inside.
Outside cooler. So you can say that the temperature.
Wow.
We gone crazy. Hey, Sam, are you okay? Are you still awake? Okay, temperature outside is cooler than inside, yeah? So outside cooler, do you understand? This is important or not? Condensation. So in Singapore, if your inside is cooler than outside, your mist will form outside. Do you understand? Do you understand? You must be able to switch here and there, no? Okay. Next.
Nintendo Switch.
Oh man, you're obsessed. Okay, so Sharon decided to increase the fan speed based on your answer. Explain how this will stop more mist from forming. Come, please type your answer. Increase the speed. How come this will stop more mist from forming on the screen? Okay, the question here is why did it take less time for the water droplets in P to evaporate? It's not about why did the temperature decrease. See the problem? Yeah, actually okay. Sorry. Okay, I will accept your answer. Right. The question, sorry, one more time. The question is not about which one is faster. Correct? Only part B is about that. Part A is why did the temperature decrease? Okay, good. Okay, it's about why did the temperature decrease? Yeah, at first I thought it's why is this faster than this? What if both the temperatures decrease? Sam? Okay, I'm gonna have to speed up, yeah, because we got quite a bit more to go through. Okay, let me see how many more. Oh, the water stuff. Okay, I'm gonna speed up, yeah. So let's take a look at this one. So for this one, the question is, why did the temperature go down? The water droplet gain heat from the hot water and evaporated to form water droplet, taking some of the. Okay, so basically heat, it gained heat, yeah. So the water droplet gained heat. So heat went to the water droplet evaporate. So hot water lose heat. That's the key thing. The hot water lose heat, therefore the temperature decrease. Okay, right? So this one is hot water lose heat. So based on Amina's result, what can she conclude about the property of X and Y? So X must be a better conductor, right? X is a better conductor of heat. Let's put here. Better conductor of heat than Y. Okay, so that's the conclusion. Okay, I'm gonna speed up, yeah? Zoo. Okay, next, you see, I'm going straight to the question. Explain why the temperature of the water decreases with time. So, can you see? This one has got a bigger exposed surface area, this one has a less exposed surface area. Now, the temperature decrease with time is because it's the same as previous one, right? The water evaporated.
More.
Hmm?
The water evaporated.
Yeah.
So because
Okay,
there's
so
a more exposed surface area
when water evaporated,
evaporated.
they remove the heat
Then the heat
water.
from the hot water and hence the hence the temperature will hence the temperature of the hot water is
Decrease, yeah. So how the surface area affects the rate of cooling? So basically, you see that A achieves a lower temperature faster. Yeah. So the bigger the surface area of water, the faster the rate of cooling. Okay, because bigger surface area means more faster rate of evaporation. Right, that is over here. Next one. Okay, I'm going faster already. Wood. Okay, next question is about the terrarium. Would terrarium A or B have a higher amount of carbon dioxide? So here there are holes. There's a snail here. Is that a snail? I think this is a snail. Yeah, there's a snail. There's like a snail. So it will be A, right? So terrarium A will have more higher amount of carbon dioxide as far. Why? It does not have holes, so the carbon dioxide cannot escape. Right, but whereas here there are holes, so the carbon dioxide can escape. Okay, so don't need to copy this first. Just looking for water droplet again. See, she realized that there are water droplets on the inner side of the terrarium. So here there are water droplets. Drop inside. Water droplets inside. Why are there water droplets inside? Because when the water vapor here touch the cooler inner surface, okay, you don't have to write, right? Enough already, right? So you just listen, yeah, just listen. Warm water vapor touch the cooler inner surface, lose heat, condense, form water droplet. Simple? Is it okay? Important, yeah? So here, why no water droplet? Because the water escape, yeah? It's like the hot bun question, okay? Next one. Okay, which liquid has the greatest rate of evaporation? Boiling point 50, 65, 80,
P.
10, 10, 10. Okay, so this one, P. At first there's 10, then after that there's 2. So P. Why? Because the volume at the end of the liquid, end of the experiment was the least. It has the least amount. So this one between the boiling point is rate of evaporation. Boiling point. So the lower the boiling point, the relationship question, right? So lower boiling point, higher rate of evaporation. Relationship question. So here. Okay, well, how using analytical gauge? Okay, this one don't want to talk about. Fair test. Another one. What happened to the amount of water vapor in the air after 10 minutes? So we're talking about water vapor in the air here. Here. This is cold, cold. So water vapor in the air. What happened? Warm. Okay, this is cold. So the warm water vapor touch this thing, right? And then what happened? Condense become water droplet here. Now, because they condense to form water droplet here, you remove the water vapor, right? So what happened to the amount of water vapor? It decreased. The amount of water vapor decrease. Why? Because they come to contact with the cooler outer surface of the glass, lost heat and condense of water droplets. All right. Next one. So now we change scenario. What happens to the water after 10 minutes? Now you put hot water. What happened to the amount of water vapor in the air? Here. Just now cold water. Cold water we know it condense. But how about warm water now? I put warm water here, hot water here. Any change? No, remain the same. Okay. So remain the same. No change because no condensation, no evaporation. Everything happened inside the box. No condensation, no evaporation. Okay. Draw where the water drop in the diagram with the hot water. Okay, so draw already, yeah. So water droplet form here. They form inside the glass. Water droplet forms inside, not outside. Okay, so explain how each of the following allow the temperature to become lower. Alright, so he put 3 big pieces of wet cloth, and then he used a fan to blow the wet cloth. Then the whole room become colder. You got it? He put this setup in the room. It's wet, so no aircon.
What do you call that? It's so much. It's magic.
Maybe that's behind the work of this.
Basically, because the cloths are wet, right? The water absorb the heat. Okay, water absorb heat. Then you switch on the fan, the water evaporate. So the room lose heat when the water evaporate. Because the evaporation of the water remove heat from the room. You got it? So you don't need aircon, yeah? You can try this at home. So are you going to try this at home?
Yes.
Yeah, get one wet cloth.
Don't need to waste morning.
Yeah, don't need to waste
Although using 2 fans might be wasting more money than using 1 aircon.